Today's topic of discussion is complex fractions, which are also sometimes called compound fractions. And the general idea is it's just a fraction within a fraction. Okay. And the basic idea is that we're going to start by just simplifying the numerator and denominator separately. And then we'll just divide them like how you normally divide fractions. Okay. So these are basically just a combination of an adding problem and a division problem. Okay. So they're not as crazy as they look. So here's an example using some real numbers without variables in them, right? So say we had something like 1/3, and then we were dividing 1/3 by 2/5. Okay, so this would be a compound fraction because they're fractions within fractions. And what we would do is we'd say, well, we're doing 1/3 and then we're dividing it. Remember, fraction lines are just dividing. So divided by 2/5. So that is the same as writing that, okay, which we know is the same as doing this. So that is basically how we're going to get our answer. Now, typically I jump straight from here to here. I don't go through this middle step, but that's what we're doing is we're just saying we're dividing these two fractions and then we're going to flip it and multiply. Okay, so let's deal with this guy. So the first thing that you want to do is just make sure that you are really clear about where the big fraction is. Okay, so what I kind of do is I go through and I make that big line a little bit longer so that it's really obvious where the split is. Okay, all right, so the top part's already simplified, no need to worry about that. But the bottom part, see, I'm gonna have to multiply this one by 4 top and bottom, and this one by x. Okay, so then I have 3 over x divided by, and down bottom, this is going to be x plus 8. So I'm going to go ahead and write that as x plus 8 over 4x. Okay, and then keep the first one the same. So the top part stays the same. Change it to multiplication, and then we're going to flip it. And then from there, check for any common factors. So like these x's will cancel each other out, and then we just simplify. So that'll be 12 over x plus 8. Okay, notice that the 12 and the 8 don't simplify, right? Because that's not a factor. Okay, and that's it. That's our answer. Okay, so they're not quite as terrible as they look. All right, next guy, this one. So again, I like to just really make it really dramatic where that fraction midline is. All right, and then we're going to do each half separately. So the top part, I'm going to multiply this side, top and bottom, by 5, and this side, top and bottom, by 3. So that's going to work out to 3x plus 10, right? Over 15. Okay, and then on the bottom, I'm going to stick a 1 under that to make it a fraction. And then this guy would have to be multiplied by 3 top and bottom to get common denominators. So I'm going to end up with 12 plus x, or x plus 12, over 3. Okay, first one stays the same. Change it to multiplication and flip the second one. And then I'm just looking for any common factors. Looks like 3 goes into both of these. And that's it. So 3x plus 10 over 5 times x plus 12. And there we go. I actually kind of like compound fractions. For all that I don't like adding and subtracting, I do kind of like compound ones. It's just, I don't know, I find it somewhat satisfying to take something that looks like this mess and turn it into something that looks like that. All right, top part's already simplified. The bottom part, so let's see, I'm going to have to multiply this side by x plus 1 and this side by 3. So I've got 3 over x plus 1, all divided by, let's see, that would be 6 plus x plus 1. So 6 plus x plus 1 is x plus 7. Great, and then first one stays the same. Change it to multiplication, flip the second one. And then we look for any common factors. So the x plus 1s will cancel, and that's it. So 9 over x plus 7. So notice how I didn't multiply this denominator out. Okay, don't multiply out the denominators. Leave those in factored form. You do, however, need to multiply out the numerators because you're adding the numerators and you need that fully simplified. Okay, so anytime it's the denominator, you gotta just leave it the way it is. Okay, but if it's in the numerator, then you gotta simplify it completely. All right, this guy. So here's my big fraction line. Top part's all set. This one I have to multiply by x minus 2, top and bottom. This one by x plus 1, top and bottom. So top part stays the same. This is going to be, let's see, so that'll be x plus 1, right, over x plus 1 times x minus 2. And this guy's going to be 3x minus 6 over x plus 1 times x minus 2. And then rather than writing out a whole new step, I'll combine that as I rewrite my next step. So the first one stays the same, change it to multiplication and flip it. So the denominator is going to be x plus 1 times x minus 2. And then I'll go ahead and combine these. So x plus 3x would be 4x. 1 plus negative 6 would be negative 5. All right, those guys cancel. And that's it. And that's our simplified form. All right, this one we got a lot going on with. Okay, so let's take a look. So top part, I'm gonna have to multiply this side by x and this side by x plus 1 to get our common denominators. So that's gonna give me 4x plus 4 and then plus 6x, right? Over x times x plus 1. Excuse me. And then down here, stick a 1 under that to make it a fraction, and this one needs to get multiplied by x plus 1 top and bottom. So that will be, let's see, 5x plus 5 minus 3 over x plus 1. And then I'm going to kind of simplify as I change my setup here. So this is going to simplify to 10x plus 4 over x times x plus 1. Okay, and as I flip, the x plus 1 comes to the top. And down here, I can simplify that to 5x plus 2. Okay, these guys will cancel. And then be careful because there's actually another thing that'll cancel here, right? 10x plus 4, I can factor out a common factor of 2, right? And then those 5x plus 2s will cancel. So this whole thing simplifies to just 2 over x. Right, which is satisfying. Going from that to that, I like that. It's pretty nice. Okay, this guy right here. So same deal. Here's my big fraction line. So if I stick a 1 under this, I have to multiply this side by x minus 2. So that's going to give me 3 and then plus 2x minus 4 over x minus 2. And then on the bottom, this side needs to be multiplied by x minus 2, and this side needs to be multiplied by 3. So that's going to be 6x minus 9, and then plus 2x minus 4. All right, so simplifying as I go. So these guys, that simplifies to 2x minus 1. Change it to multiplication, and then flip. So 3 times x minus 2. This would simplify to, let's see, 8x minus 13. So these guys cancel. That doesn't factor anymore. So that's it. 3 times 2x minus 1 over 8x minus 13. And we're good. Sorry, can't see that. All right, now these last two problems are a little bit different, okay? So these ones are just a tad different from the ones that we've been looking at. No big deal, okay? It's because we have these negative exponents, okay? So negative exponents, remember, flip. But I can't straight up flip this to the denominator because it's being added to something else, and that sort of messes things up. So what we're going to have to do is I'm going to rewrite this as 1 over a plus 1 over b, all divided by ab. Okay, and then I'm going to simplify that from there. So I'm going to multiply this one by a and this side by b to get my common denominator. So that's going to give me, let's see, b plus a over ab. And on the bottom, just to sort of help my brain to function a little bit better, seeing the different parts of this fraction, I'm going to go ahead and stick a 1 under that, right? Because now I'm like, oh yeah, I can clearly see the two fractions and where like the big divider of the fractions is. Cool. So then from there, b plus a over ab, and then change it to multiplication and flip it. Oh, did you think those ab's were going to cancel? I thought the ab's were going to cancel. I'm a little disappointed. So that simplifies to ba over a squared b squared. And there we go. All right, next one. This one I like. This one I find very satisfying. Okay, so what we're going to do with this guy, right, is the a gets flipped, but the b doesn't, right? So that's going to become b over a. And then minus on this one, the b gets flipped, but the a doesn't. So a over b. Right, and then it's all divided by a plus b, which I'm going to, again, stick a 1 under, just so that it helps my brain see the structure of this a little bit better. Okay, so this guy, I'm going to multiply top and bottom by b. This guy, multiply top and bottom by a. So I'm going to get b squared minus a squared over ab. And that's all divided by a plus b over 1. Okay, so that's b squared minus a squared over ab. And then I'm going to flip it. So it's 1 over a plus b. And then we're almost good, but this guy, that factors, right? That's a difference of 2 squares. So I'm going to go ahead and factor this to b minus a times b plus a. And b plus a and a plus b, those are the same thing. Sometimes if they're backwards, you might have to do that thing where you pull out the negative, right? But in this case, that's the same thing, so we're all set. So I'm left with b minus a over ab as my final answer. Okay, and there you go. Now, one thing to watch out for, because this is a common mistake that I see people make. If you had b squared minus a squared and it was over b minus a, right? We had a plus b, but say it had been b minus a. What I see a lot of people do is they try to somehow say like, oh, well, that cancels to just b minus a, right? Because, oh, b squared and b and a squared and a, and they just kind of go, and then call it a day. It doesn't work that way. Okay, so you got to make sure that you actually factor it out. Okay, so watch out for that and just don't make that common mistake.